All right, well, welcome to the first and actually only video for 9.7. There's really only two things that we're going to go over in this section for Algebra 2. There's other stuff, but you're not going to use that until you get to other math classes, so we're not going to go over that right now. What we're going to learn in this section is called the Pythagorean identity. So you see in your journal there's a lot of different identities here, but we're not going to be focusing on all of those. The two that you need to know are the tangent identity and the Pythagorean identity right here. So the tangent, and we've gone over this before. If you remember, we know that in a unit circle that the sine of a angle, sine of theta, is equal to y, and the cosine of theta is equal to x if x and y are a point on the unit circle. We know that sine and cosine equals x or y and x respectively. And tangent is just equal to y over x. We get tangent equals y over x. Now here, the way we get our tangent identity is just by substituting. If instead of y, if we plug in sine of y, and instead of x we plug in cosine, we get tangent equals the sine of theta over cosine theta. So that's your first identity. That's a relationship between the tangent, sine, and cosine. Tangent is just equal to the ratio of sine theta over cosine theta. So again, the tangent of any angle is just equal to the sine of that angle divided by the cosine of that angle. That's our first identity right there. The second one is the Pythagorean identity. Now, when we get into class and you do the exploration, you're actually going to see how we come up with this identity right here. But the key thing is that the sine squared of an angle plus the cosine squared of an angle equals 1. That's our Pythagorean identity. So those are the two that you're going to need from this section, okay, the tangent and the Pythagorean. Make sure you have those written down in your notes right now. So let's go ahead and let's go back and look at our first problem right here. So here, now you know some other ways to solve for these, but we're gonna do this problem using the Pythagorean identity. It's important that you know this. On the test, you're going to be asked to solve a problem like this using the Pythagorean identity. So if you don't use the identity and you do it a different way, you won't get credit for it. So you have to make sure you remember this. All right, so given that the sine of theta equals 4/5 and theta is between pi over 2 and pi, find the values of the other 5 trigonometric functions. Now, remember, we're just going to look at the other 2 functions right here. We're going to look at, we want to find cosine and tangent. Now, the first thing is to understand what this means right here. This range, theta is between 2 pi and pi. Remember, if we look at a coordinate plane, we start out, there's 0, here's pi over 2, and here's pi. And remember, if we keep going, down at the bottom is 3 pi over 2, and ultimately when we get back to 360, we're at 2 pi. So what this is telling us is that our angle is between, it's greater than pi over 2, so greater than pi over 2, and less than pi. So we know that theta is in quadrant 2. Okay, that's going to come in handy a little bit later in this problem. Okay, so remember, in a little bit when you see the steps, you're going to see that we know that theta is in quadrant 2. The reason we know that is because of this statement right here, this range. Okay, so we know that the sine of theta is equal to 4/5. So the first thing we want to do is we know that the Pythagorean identity just uses sine and cosine. So we can actually use the Pythagorean identity to solve for the cosine of this angle. So what we want to do first is, let's go ahead, we're going to solve for the cosine, and let's write out our Pythagorean identity. So we know that the sine squared of theta plus cosine squared of theta equals 1. Well, now, since we know the sine of an angle, the sine of theta, we can go ahead and substitute that in here. And now we just have an equation that we can solve. So we get sine is equal to 4/5. So 4/5 squared plus cosine squared equals 1. Now we just have to go ahead and isolate cosine. So we subtract, now remember 4/5 squared is 16 over 25. So we get 1 minus 16 over 25 is equal to cosine squared. If we go ahead and combine these, 1 minus 16 over 25, that's just 25 over 25 minus 16 over 25. We get that the cosine squared equals 9 of 25. And if we take the square root of both sides, we get that our angle, cosine, is equal to plus or minus 3/5. Now remember, because we took the square root of this, our cosine could be equal to plus or minus 3/5. Now, here's where having this range is helpful. We need to figure out what our sine is of cosine. So if you remember, we showed that because this is in quadrant 2, if you remember, we've got our little acronym that we use. So remember, it's all students take calculus. So we start from quadrant 1 and write out our acronym in each quadrant. So 1, 2, 3, 4. In quadrant 2, only the sign is positive. So what that tells us is that because our angle is in quadrant 2, the cosine must be negative. So there we've got our cosine now. So we've used the Pythagorean identity and the fact that we know the sine of theta to find the cosine. So right now we've got 2 out of our 3 trig functions. We know that the cosine is equal to negative 3/5 and the sine of theta is equal to 4/5. Let me go ahead and zoom back out of here. So cosine theta is negative 3/5, sine theta is 4/5. We have our other identity. If we go back over here, we've got our tangent identity. And the tangent is just equal to the sine over the cosine. So we can take our 2 values, 4/5 and negative 3/5, and plug them in. So tangent equals sine over cosine, which is 4/5 over negative 3/5. When you go ahead and do your copy dot flip, the 5's cancel out, and you get the tangent is equal to negative 4/3. So that would be your answer. That's how you use the Pythagorean identity to find the values of the other trigonometric functions. And again, remember, there's other ways you can do this. This specific problem is having you demonstrate your knowledge of the Pythagorean identity. So be prepared on the test. You're going to be asked a question. How do you find the other trig functions using the Pythagorean identity? If you don't do this, if you don't use this theorem, then you're not going to get credit on that. Let's look at one more example just to make sure that everyone knows how to do this. So let's go through the steps again. So again, make sure if you had any questions on the last one, we're going to do the same steps over. So here we know that the sine is equal to negative 5 over 13. We know that theta is between pi and 3 pi over 2. So if we look here, here's pi and here's 3 pi over 2. So that tells us that our angle is in quadrant 3. And remember, when we do all students take calculus, so we know in quadrant 3, we know that the tangent's going to be positive and both sine and cosine are going to be negative. Now look right here, this makes sense. Our sine is equal to negative 5/13. So that matches up right now. So we need to find the cosine of theta and the tangent just using our identities. So let's first write out, we get sine squared of theta plus cosine squared theta equals 1. So this right here is our Pythagorean identity. So your first step, now that we know what quadrant it's in, our first step is to write this out. Now let's take negative 5/13 and plug it in here. So we get negative 5 over 13 for the sine squared, or for the sine. So negative 5/13 squared plus cosine squared equals 1. All right, so now we're down to, we've got one equation with one variable in it. We've got our cosine. So now we just solve. So we're going to end up with cosine squared. Here we go. Pardon my writing a little bit, takes a little bit. Cosine squared, now it's just going to be 1 minus 5 over 13 squared. Now, when you square negative 5/13, it turns into a positive. So this is going to be 1 minus 5 squared is 25, and 13 squared is 169. So we get cosine squared theta equals 1 minus 25 over 169. Now we have to go ahead and combine this. So let's turn 1 into a common denominator. So 169 over 169 minus 25 over 169 equals 144 over 169. Okay, so now we've got our, we're almost there with cosine. We've got cosine squared theta equals 144 over 169. If we take the square root of both sides, square root of cosine squared just gives us the cosine of theta. And the square root of 144 over 169, now remember, because we're taking the square root, it's plus or minus. Square root of 144 is 12, and square root of 169 is 13. So here we've used our Pythagorean identity to solve for the cosine. Now we know it's plus or minus 12/13. So we need to again go back to our range right here. Because we know that it's in quadrant 3, again because theta is greater than pi and less than 3 pi over 2, we know that it's in quadrant 3. We know only the tangent is positive. So we know that our cosine must be negative. So that's how we're able to figure out if our cosine is positive or negative. Okay, so there is our first part. We know that the cosine of theta equals negative 12 over 13. Okay, so now we use our Pythagorean identity when we know sine or cosine. And we can substitute one in and then solve for the other. Now, we have to remember for the tangent, remember our other identity, tangent of theta is just equal to the sine of theta over the cosine. So we're using our tangent identity right now. So sine of theta over cosine of theta. Since we know both the sine and the cosine, this is just easy. We just plug these values in and we get it. So the sine is negative 5 over 13, and that's divided by negative 12 over 13. So we get negative 5 over 13 divided by negative 12 over 13. When we copy dot flip, the 13s cancel out, and we get 5 over 12. Okay? So that's, the negatives end up canceling, and again, you copy dot flip, the 13s cancel, and you get the tangent equals 5 over 12. So that's how we find our other two functions here. So using our Pythagorean identity and our tangent identity, we have found the cosine and we have found the tangent of our angles. Okay, now what I want you guys to do, again, I did two examples, so you can go back through and watch both of these. I want you to go ahead and do, where's the problem? I believe it's in here. I want you to solve number 1 right here. So given that the cosine is 1/6 and you've got your range for theta, I want you to use the Pythagorean identity and the trig identity, or the tangent identity, to find the sine and tangent of theta. So go ahead, sine and tangent of theta, and go ahead and plug those in right here.